There, this is calculus for section 6.5, and before I dive into 6.5, I just want to emphasize one thing from yesterday that I hope we put into our notes. If you didn't get it into your notes, those two definitions or formulas we found in section 6.4 about work, make sure that both of these boxed ideas are in your notes for section 6.4. They're also found in the book on page 447, or you can pause now to copy those in your notes. Okay, so today is 6.5. We're doing the average value of a function, and this starts in your book on page 451, if you'd like to follow along for that. So we've defined the average value of f on an integral, and this is a red box that's provided for us on page 452. So on page 452, I want this going into your notes, and it's right here. So we've date and title 6.5, average value of a function. We've defined the average value of f on the interval from a to b as f average equals 1 over b minus a times the integral from a to b, the function f of x dx. Okay. Pause that now or have it open in your book on 452 and copy that. Make sure that gets into your notes. Okay. So let's dive into an example for this. This will be the example number 1 on page 452. We are asked to find the average value of the function f of x equals 1 plus x squared on the interval -1 to 2. Okay, copy that down. Now, I would first start by copying what you're going to plug into. This is like your magic formula you're plugging into. So copy this down, and also other first step, we're going to define our a and b. Okay, a being on the left of the interval -1 and b being the 2. Right? A is the smaller, b is the bigger. So let's define both a and b, and let's copy down our formula to plug into. Okay. Something like that. I've defined my a to be -1, my b is 2, and I've got exactly what to plug in here. I know what my function f of x is. That's going to be placed in there. My a, I can pop into those two spots, and my b of 2 can pop into those two spots. So let's go ahead and plug in, and be careful that there is a minus there. You're subtracting a, and a also happens to be negative. So be careful as you do that step. Go ahead and do that now on your paper. So I have b minus a, 2 minus -1. 2 minus -1 becomes a 2 plus 1. 2 plus 1 becomes a 3. So we have a fraction 1/3 is multiplied outside of that integral there. So let's rewrite that as 1/3. Okay, we have the integral from -1 to 2. So I've replaced f of x with the function. That just comes right from the given. We're told f of x equals 1 plus x squared. So I've plugged that in. I've used parentheses. So we know that whole thing is the function dx. Now let's take the derivative of that. We've got you try it on your own first, and then we'll see what we get. Okay, let's take the derivative of that. We've got the 1 becomes an x, the x squared, so that n is 2. That's an n plus 1, so 2 plus 1, so that becomes a 3 up there. That'll be all over n plus 1, for n is 2, 2 plus 1 is 3, so that becomes x cubed over 3 plus x. So let's rewrite that. Okay, so we've rewritten it as that, and now we're going to evaluate it for the integral. So from -1 to 2, we have a 1/3 out front, x plus x cubed over 3. That's how I should write it, right there. Okay, so now we're going to evaluate this. So I want to know what happens when I plug in a -1 for x. So right there and right there, and don't put it into decimals yet. Keep fractions, so you might have to find a common denominator through parts of these steps. So see what you get when you plug in -1 for your x's, and then do the same thing again. You're going to get your other answer when you plug in 2. Every time you see an x, plug in a 2 and see what you get. Again, don't turn it into a decimal yet. It'll be more accurate, and we'll get down to that whole answer as possibly a fraction or possibly a whole number for these examples today. So we'll get each of those two numbers after we evaluate them, and then we're going to take the b minus the a, or the output of using the 2, subtract away what our output is when we use the -1. Okay, so go ahead and do that now. Plug in a -1 and a positive 2. Running out of space here. Okay, so 2 plus 2 cubed. I started with just the 2. So 2 plus 2 cubed over 3. And you could also distribute the 1/3 now, or you could just keep it and do it at the end when you find both. Either way works. So now let's plug in the -1 for both. So that we're subtracting away. -1 plus -1 cubed. -1 cubed, careful, is actually a negative over 3. So then that becomes we're subtracting these two, a -1 plus -1 over 3. A -1 needs a common denominator of 3, so it becomes -3 over 3. Combine with our -1/3 there. Still have the 1/3 out front. So I'm running out of space here. Okay, so we've evaluated it with, okay, from -1 to 2. So here I've plugged in 2 every time I saw an x there. So that became an x plus x cubed over 3. X cubed is 8. I changed 2 to have the common denominator of 3, so it's now a 6/3. So it's 6/3 plus 8/3, which I'll write on the next step. And so the other integral, you could have done this separate. I just put them next to each other with a subtraction, because eventually we're going to be subtracting, and it's this whole thing there. So plug in -1 there and there. So you got a -1 plus -1 cubed all over 3. Careful, -1 cubed is a -1 over 3. Let's change that -1 to have a common denominator with the 3. It becomes -3 over 3. Now we can add those, right? That plus sign there. We're adding those. -3 plus -1, that gives us a -4/3. So write your next line down there. Space. Okay. So I have a 14/3 minus a negative 4/3. So minus a negative, that becomes a plus, and those are common denominators. So it's 14 plus 4 all over 3. 14/3 plus 4/3, and we got our 18/3. And then don't forget, we still have that 1/3 who's been waiting on the outside, and he can get multiplied on there. So we're multiplying two fractions, so you go straight across the top and straight across the bottom. So we get 18 in the top and 9 in the bottom. Oh, look at that. Good thing we didn't use some rounded fractions up here earlier, because now we have this beautiful whole number. This fraction reduces to a beautiful whole number. 18 divided by 2. 18 divided by 9 is 2. So your answer is just a 2. There we go. Okay, let's go back real quick, recap. I might show you a little bit different way to do this. So we had our definition of our average value of f defined on the interval a to b. So we've copied that down. We were given a function. We were given an interval a to b. So I defined a and b, and that goes on the integral. Small number a on bottom, bigger number b on top. And then we also have 1 over b minus a, which gave us our 1/3. It's being multiplied on the outside of the integral. We have our function dx, took the derivative, we got x plus x cubed over 3, and then we've evaluated our integral at -1 and at 2. Now I did both of those kind of side by side. You don't have to, and I also kept 1/3 and I multiplied that on at the end. You also don't have to do that. So I'm going to show you the other way, and we'll still get the answer of 2. So say that I just want to evaluate one number at a time all the way through. We're going to try it that way. So let's start with 2. So I'm going to plug in 2. There we go. Let's do this. Okay. So we got 1/3, 2 plus 2 cubed over 3. Okay, so I've plugged in 2, and I'm just going to get it all the way out to an answer and not worry about the -1 yet. Okay, so 2 cubed is 8, so we have 8/3, and 2 plus 8/3, we need a common denominator, so we multiply the 2 by 3 over 3, which gives us 6/3, and now those have common denominators, right? We can only add or subtract when we have the same denominator. So now we can add those. 6 plus 8 is going to give us the 14 over 3. And then that's a fraction. We can multiply the 1/3 from the outside. Two fractions, you multiply straight across the numerators, straight across the denominators, and we get our 14 over 9. Okay, and that doesn't reduce right now. That doesn't reduce. And this is just for the 2. We just plugged in the 2 there. So now I'm going to go through that same process with the -1 and see what we get. So copy this, and now you're plugging in the -1 there. Okay, copy the same thing using a -1. And then -1 cubed gives you a -1 over 3. Okay, so we have that, and now we want to add. So we need a common denominator. That has a 3. We're going to multiply the -1 by 3 over 3, because that's a whole number, whole 1. You can multiply anything by 1. And then we have a -3 over 3 minus 1. So those are common denominator. Oop, that was a plus, sorry. Plus a negative, so you could just say subtract too, right? Plus a negative would be the same as subtract. So -3 minus 1, and they have the same denominator, so we keep the denominator. -1 minus 3 gives you a -4. Okay. And we've got our 1/3 there, multiply across the tops and bottoms. -4/9. Okay, so that was for our -1. This was for our 2, and remember we're taking b minus a, the big one minus the small one. So we used we have 14, so for b minus a, 14/9 minus -4/9. So 14/9, we're taking b, when we evaluate the integral at b, we got the 14/9. So when we evaluated the integral at a, we got -4/9. And now we're subtracting the two. It's b minus a. A happens to be a negative. So you're subtracting a negative. Subtracting a negative makes it a positive. Same denominator, so it's 14 plus 4 all over 9. 14 plus 4 all over 9 is 18/9. And 18/9 now we can reduce to 2. Okay? So 2 different ways to work yourself through that average value of f. And you can see we got 2. Where did it go? We got 2 both ways. So the work spilled on. So here was the first way. You need to copy, pause, or take a look at that again. Here was our first way, and we got 2. Did it again, and we got 2 this way. Okay, let's do another one. And this will be exercise number 1 found on page 453. So I've copied down the problem. It says find the average value of the function on the given interval. The function equals at 4x minus x squared. And our interval is 0 to 4. Okay, so we're right like only 0 to 4. You can be 0 and you can be 4. And you can be anything in between, and an infinite number of things between 0 and 4 that you can be. So we're on that interval. And then I've copied, this is our red box that we've already copied into our notes, but we copy it for every problem. And then I'm going to define what is my a and what is my b. So this is the interval a to b. So my a is 0 and my 4 is b. Let's fill those in. Okay, now I'm going to use this in here and use this in here and rewrite it. So go ahead and write it on yours. Okay, so I've got 1 minus b over a, so 1 minus 4, sorry I said a, over, let's do that again, 1 over b minus a, our b is 4, a is 0, so 1 over 4 minus 0, which reduces to 1/4. We have the integral from a to b, so from 0 to 4, and then we have the function, which came from our given up here, 4x minus x squared, right? Replace the f of x with what f of x is equal to, it's the function, dx, okay? So we've got 1/4 out front of the integral, and now let's take the derivative of this. So this becomes 4 stays, exponent on that is a 1, so n is 1, 1 plus 1 is 2, that's now an x squared, all over n plus 1, n was 1, 1 plus 1 is 2, so all over 2. So this is 4x squared over 2. 4x squared over 2 reduces to 2. So 2x squared. Okay, and then we copy the minus sign. This is, our n is 2, so n plus 1, that's now x cubed, all over n plus 1. So x cubed over 3. Copy the minus, x cubed over 3. There we go. Okay, and now we want to evaluate the integral 2x squared minus x cubed all over 3. We're going to do this from 0 to 4, and I love these problems that have 0 in it because take a look. You already know if you put a 0 in there and you put a 0 in there, it's 1/4 times 0 minus 0. I mean, it's just your answer is 0. So we don't have to do any work really to evaluate the integral at 0. We know it is 0. Awesome. So really we're just going to do the work for 4, and then we technically subtract 0 from the answer we get when we plug in 4. So do your work for 4 on yours. Okay, so we've got 2 times 4 squared minus 4 cubed over 3, and all of that is times 1/4. Okay, so let's do, that's 2 times 16, so 32, and then we have minus 4 cubed is 64 over 3, and now we need a common denominator. We have 32 and we want to subtract 64 thirds, so we need that to have a denominator of 3. So let's multiply that by 3 over 3, because that's the equivalent of 1. You can multiply anything by 1. And 32 times 3 is 96. So we now have 96 over 3 minus 64 over 3. Now we can, those are like terms, and I'll carry down that 1/4 is on the outside still. So those are now like terms. We can now subtract. So 96 subtract 64 with the 3 in the bottom. I won't forget my 1/4 out front. So we have 1/4. 96 minus 64 is 32 over 3. And that 1/4, we're multiplying that 1/4 on our 32 thirds. And when we multiply fractions, straight across the numerator, straight across the denominator. So it's now 32 over 12. Okay. 32 over 12. All right, that's an even number. We know that can be reduced with a little trial and error, or with your calculator, you can see that 4 goes into both of those. 32 divided by 4 and 12 is divisible by 4. So 8 and 3 is our reduced answer. So 8 thirds is our reduced answer there. Okay. So that's our average value of the function on the interval from 0 to 4, right there. 8 thirds is the average value of this function in the interval from 0 to 4, between 0 and 4. Okay, so that's your final answer there, 8 thirds. All right, let's do one more. This is going to be exercise 3 on page 453. So we are given g of x, right? Just another name of a function, g of x, just like f of x. G of x equals cube root x, and our interval is 1 to 8. So go ahead and copy that down. Our directions are the same. Find the average value of the function on the given interval. So first steps, we're going to copy down our formula and define our a and b. Go ahead and do that now. Okay, so copy the formula. I've defined my a is 1, my b is 8. That's the interval from a to b. So now let's plug those in. I've got my function. I know that says f of x, but you guys know g of x. That's the function. So you'll just put cube root x in place for that f of x. Go ahead and fill that in now. Okay, so I've got 1 over b minus a. B is 8, a is 1, 8 minus 1. We've got 1/7 as our next line there. And now I've got my function plugged in there, cube root x, dx. So let's take the derivative of that. First, I don't like a cube root, so I'm going to change that to have an exponent. And remember, like a square root is the same as having a 1/2 exponent. Cube root would be the same as having a 1/3 exponent. So let's change that to, or think of it as x to the 1/3. I'm just going to write it next to that, because that's equal to x to the 1/3, and that'll make this easier. So x to the 1/3. Okay, the exponent is 1/3. Now think 1/3 minus 1. 1/3 minus 1. And 1, we can change that to 3 over 3. So you have common denominators, okay? 1/3 minus 3/3, so we have a negative 2/3. Sorry, not minus 1, plus 1. plus 1. Sorry about that. Plus 1. So 1/3 plus 1. So we now have 4/3. 4/3 there. So we have x to the 4/3, and then we know we put that in the denominator too. N plus 1 goes in the denominator. So it's over 4/3. Okay, so x to the exponent of 4/3, and then in the denominator 4/3. But now you guys know you can take like the reciprocal of that. So we can make this 3/4 up in the numerator now. So 3/4 x raised to the 4/3, like that. Okay, now we're going to evaluate this on the integral from 1 to b. So we can plug in 1 and then plug in 8. And don't forget we have the times 1/7 on the outside. So let's do this from 1 to 8, the 1/7, okay? So let's do the 8 first. We can do 8, and I would just use your graphing calculator. Use parentheses when you're doing your exponents. So you could do it by hand too, but we have this beauty, so let's use it. All right. Your calculator will do order of operations, so you can do 4/3 times 8 raised to the parentheses. Oops, 3/4, sorry. 3/4 on the outside times 8 raised to the 4 divided by 3 in parentheses. And it'll follow those order of operations. It'll do that exponent first on the 8 before it multiplies it by 3/4. If you're unsure, don't want to do it that way, that's fine. You can do it in pieces. Okay, and we get a 12. And don't forget there's a 1/7 multiplied outside of this. So we got a 12 there when we evaluated it at b. So it's a 12. Remember, we're doing b minus a. So 1/7 out there. All right, now let's do the same thing with the 1, and a little shortcut. If you guys used second entry, so second being that blue second key, and then down by enter, you'll see entry. So that'll copy, don't hit enter yet, but second enter, and it copies the exact last entry that you did. And all I have to do is arrow over to that 8. So arrow, 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 all the way over to the 8, get your cursor hovering over the 8, and then I can press my 1, and it replaces that 8 with a 1, and I didn't have to do any of the other work. So let's hit enter, and we get 3/4. Okay, 3/4 there. And I did not multiply by 1/7 yet, so we'll have to do that at the end since we didn't do it for each of these. Now, we remember it's b minus a, b minus a. So when we put 8 in here, we got 12. When we put 1 in here, we got 3/4. So let's subtract those two. Let's see, let's keep common denominators. So 12 times 4/4, so 48 over 4 minus 3/4, like that. And then 48 minus 3 for our 45 over 4. So 45 over 4, and now, if you hadn't done it before, let's multiply that by 1/7. So then we got 4 times 7 in the bottom. 45 over 28. Okay, and then we would see if that reduces, and if you can test find the prime factorization of 45 and 28, and they have no common factors in them, so you're done, you can't reduce this. So we'll leave this here as 45 over 28, and that is our final answer for that one. Okay, you can pause that there if you want to see and copy any of that work into your notes still. All that work is there now. All right, thanks guys. See you tomorrow.